The last thing that we're going to take a look at in this lecture is the idea of a way that you can measure the relative humidity of air using two thermometers. And one thermometer is just measuring standard atmospheric conditions. It's what we call a dry bulb thermometer. And the other one is a thermometer with which it could be a cotton swab that is wet. And consequently, that would be measuring what we call the wet bulb temperature, which would be temperature with 100% relative humidity, fully saturated air. So the concept, or what we're going to take a look at, is dry bulb, wet bulb temperatures. Now there are electronic ways that we can measure these things, probably using things like conductivity of the air. But this is kind of an older traditional way. It's a low-cost way of measuring the specific, or the relative humidity, I should say, of the air. So what it would consist of is one thermometer So there we have what we call the wet bulb and the dry bulb temperatures. The dry bulb temperature is just measuring standard room air, and the symbol that we use for that is TdB. And the wet bulb temperature, what we do is we take our thermometer and we put a cotton swab on it. We put the cotton swab then into water, and water will go up through this wick, through a wicking effect. And what it will do is it will create fully saturated conditions, or we have 100% relative humidity for that measurement, and that is what we call the wet bulb temperature. With a combination of these two, we can then go ahead and do calculations. Specifically, what it enables us to do is to determine the relative humidity of the air. So we may not know it, but with this measurement we can determine it. So I'll give you the equations now that enable us to do this. So there are equations that enable us to do this, and in setting this up, what we will say is we have state 1, and that would be our dry bulb. And for this state, we're trying to find the relative humidity. So we do not know the relative humidity there. We do know the temperature at state 1 is equal to what we will call the dry bulb temperature. And then state 2, this is the wet bulb temperature. Here, the relative humidity is 100%. It's fully saturated. And temperature at state 2 is equal to the wet bulb temperature. So those are the two states. What I will now do is give you the equations that you can use to determine both the specific humidity as well as the relative humidity. So those are the equations you can use. You can see here that it's going to require going into the steam table and getting different parameters from the steam table. And with that, however, you will be able to determine the specific humidity as well as relative humidity for your room conditions with only two temperature measurements. And so that's the idea of a wet bulb and a dry bulb temperature measurement. With that, that will conclude today's lecture. What we'll be going into next time is looking at a way to make these calculations a little quicker and more efficient, and that's using a tool or a chart called the psychrometric chart. And the equations that we've looked at have been a little on the laborious side. I mean, there are things that you can work with. However, engineers like shortcuts, and the psychrometric chart enables us to make those shortcuts. So that's what we'll be looking at next time. But with that, that concludes today's lecture. Thank you very much.